Methods of proof. We want to be able to prove things instead of just giving 3 examples and saying that's good enough. I believe it. We want to work out ways of being absolutely sure that something is true or isn't true. The simplest thing you can do is a direct proof, which is just try to show that it has to be true. Direct proof. So, for example, let me. How do I do this? Prove if a number is odd, then its square is also odd. If a number is odd, then its square is also odd. Do you believe that statement?
Yes.
3 is odd and 3 squared is 9. This statement says nothing at all about the square of an even number. It does not say the square of an even number is even. It does not say the square of an even number is odd. It just says if it's odd, then its square is odd. Well, let's try to prove that. Let n be an odd number. Well, if it's an odd number, I can write it in a particular way. Does anyone remember? We did this last week, I think. How do I write an odd number? Anyone remember? You want to go, Eddie?
2a plus 1.
2a plus 1. Love it. For some integer a. 2a must be even. So 2a plus 1 must be odd. Okay, what about n squared? N squared has to be 2a plus 1 squared. And if I expand the square, what do I get? Who am I going to pick on first today? Xander. Expand the square, what do I get?
4a squared
Good.
plus 4a plus 1.
Good. I was waiting for you to forget the middle term, but you remembered it. I like it. I can factorise this. I could factorise the 4, but I'm trying to show that something is odd, so I'm actually going to take out the power of 2. Why did I do that? Because I've got 2 times an integer. Well, 2 times an integer is even. So this bit must be even. Therefore, n squared must be odd. Well, I did find a reason to use my colours. A is an integer, so all of this is integer. Any integer times 2 is even. I'm adding 1 to it, so my number must be odd. And write something at the bottom of your proof, QED.
I was going to say, do we need to write it?
You don't have to write it, it's not required.
I wrote it.
We just like writing it. For the Year 11s, do you remember what it stands for, Eddie?
Or demons, I don't know.
Yeah, it's something like that. Demonstrandum. Thus it is demonstrated, is what it is in Latin. Thus is demonstrated. I've done my proof. You don't have to write this. We just like writing it. That's a direct proof. I started with what I knew and I brute forced my way to something that has to show that the outcome is true. That's a direct proof. Let's try another one. Prove. Oh, I can't even write the word prove today. If 5n plus 3 is odd, I've got a brain here today. There's a brain stuck to the board. A brain with legs, go figure, and eyes. Okay, and a mouth. If 5 plus 3 is odd, then I think it says n must be even. Does it sound right? Yes, n is even. How would you prove that? If 5n plus 3 is odd, then 5n plus 3 can be written as... Do you want to have a go, or do you want me to show you? Nobody answers.
I'll have a go.
Have a go if you like. I'll write it up in a minute. Oh, they went the other way. They actually proved that by contradiction. I reckon we can prove it directly. Let's use A again, like he did. Doesn't matter. I'm going to use K actually. 2k plus 1, where K is an integer. So what do I know? 5n plus 3 is 2k plus 1. 5n plus 2 is 2k. 5n n is even. I reckon I can convince you once I've got to that point.
How did you get the 2k plus 1?
This is odd. I'm assuming it's odd. If it's odd, then it's equal to some even number plus 1. Must be. Every odd number can be written like this, with this being some integer. Rearrange. 5 times n is even. This is even because it's 2 times something.
But does that show that n is even?
Yes, therefore 5n is even. Because it's on the left-hand side and they're equal. But 5 is not even. 2 does not divide 5. Therefore 2 must divide n, and n is even. Have I convinced you? I have an odd number times something else, and the product is even. I can't get evenness from the 5. Odd times an odd is odd, so this number has to be even. There is another way to prove this. I might do them in a different order. Maybe I'll come back. No, let's do it now. Let me give you an alternative proof. Proof by contradiction. I'm going to give you another way to prove the same thing. If 5n plus 3 is odd, then n is even. Exactly the same thing. I'll wait for them taking notes to catch up. Okay to go on, Xander?
Yes.
Okay. So, if 5n plus 3 is odd, then n is even. Proof by contradiction says, start with something you think will contradict it, and show that you end up in nonsense land. So I'm going to assume that this is odd, but that n is odd. So I'm going to go by contradiction. And I'm going to go, suppose 5n plus 3 is odd and n is odd. Remember we talked about negation of an implication. You have to assume the first bit is true but the second bit is false. Suppose this is true but it's actually odd, not even. Well, then n has to be 2, I've used different letters so you don't get confused, 2q plus 1 for some integer q. Okay, let's look at 5n plus 3. That's equal to 5 lots of 2q plus 1 plus 3. Expand it out. Can you spot the problem? If I assume it's odd, I can prove that it's even. Something's wrong, must be my assumption. This contradicts the initial assumption. Therefore, n must be even.
Doesn't this only show it can't be like odd?
I can't have both of these things true. Correct.
Couldn't it be not true for odd and even?
I don't care. I only care about this.
Okay.
This is given to me. I know this is true. If I also assume n is odd, I get a contradiction.
But if it says like prove it's 5n plus 3 is odd, then n's even. If it's false for both odd and even values of n?
If trying to work out exactly what you're saying. I have to prove if then. I have to prove this implies that. If this is false, I don't care. If this is true, this has to be true. If that's the case, then this statement is true.
Alright.
If they're both false, then this one's false and I don't care. But to prove this, if it says if and only if, I have to prove the other way as well, then I'll care.
Yeah.
But an if then, I don't have to care. So I started with an assumption that this was wrong, and I ended up with something that didn't make sense. This can't be odd and also even. So this assumption has to be wrong. Let me show you another one that's actually on that list. Prove irrationality by contradiction. Can you see that one? Prove that the square root of 2 is irrational. And we're going to do it by contradiction. What can I contradict? Oh, I'm going to assume that the square root of 2 is rational. Assume, you can write suppose or assume, kind of the same thing. Assume square root of 2 is rational. Well, what does rational actually mean? That is square root of 2 equals p over q. And you've got to set this up carefully. P over q, where p and q are integers, q is not equal to 0, because I'm not allowed to divide by 0, and P and Q have no common factors. So if it's rational, I can write it as the ratio of two integers in simplest form. Every rational number can be written in simplest form. No common factors. Okay. If that is the case, remind myself how to do this properly. Okay. What happens if I square both sides? 2 equals p squared over q squared. Well, that means 2q squared has to equal p squared. Q is not 0, so I'm allowed to multiply both sides by q. Now, this is the bit that's the trickiest to get your head around. This side is even. That means this side has to be even. You agree? That means 2 has to be a factor of p. Therefore, p squared is even. Therefore, p is, let me just write that way. Therefore, 2 divides p. P has to be even because its square is even. Oh, we did if a number is odd, then its square is also odd. If you don't believe this, you could do the same proof. If a number's square is even, then the number itself must be even. You could do the same kind of thing. You could work that through. 2 must divide p. Okay. let P equal 2R for some integer R. If P is 2 times something, let's work out what the something is. Okay. What do we know? 2Q squared equals 2R squared. Because P is 2R. Okay. 2Q squared equals 4R squared. Divide both sides by 2. Q squared equals 2R squared. Wait a minute. If this side's even, this side has to be even. Therefore, Q squared is even, therefore 2 divides Q. This contradicts the assumption of no common factors. Because I've just shown that 2 divides P and 2 divides Q, therefore they had a common factor. Well, if this assumption is false, then it must be irrational. Therefore, square root of 2 is irrational QED. Are you convinced? It's a little bit tricky to get your head around. I'm assuming the opposite and then showing that my assumption leads to the opposite of what I started with. So this can't happen, therefore this must be wrong, it must be irrational. And you can now prove irrationality by contradiction by using this kind of argument. If it says prove the square root of 7 is irrational, you do the same thing. Except instead of 2 everywhere, you're going to have 7 everywhere. Instead of even, you just have to go 7 divides P squared, therefore 7 divides P. There are some other ways to prove contraposition. Proof by contraposition. You remember I said the original statement, the original implication, and the contrapositive are equivalent. That means sometimes the contrapositive might be easier to prove than the original statement. And it's exactly the same. Oh, we're going back to this one again. I think we already did it. Oh no, different again. Okay. Prove if 5n plus 3 is odd. Is that the same statement? Yes, it is. Then n is even. Same statement as we did before. By contraposition. Oh, that means I'm actually going to prove the opposite. I'm required to prove, that's what the RTP stands for, I'm required to prove if n is odd, then 5n plus 3 is even. Contrapositive. Not Q implies not P. Okay, Okay, if n is odd, how do I start? Let n equal to, what letter am I going to use this time? Anybody have a favourite?
X.
X, 2x plus 1 for some integer x. Okay, then 5n plus 3 is 5 lots of 2x plus 1 plus 3. We already did some of this working out. Over here, we already showed it was even, so it's going to look the same. Which is even. QED. If you like, you can have one more statement. Let me write it. Therefore, the original statement is true by contraposition. QED. So there are some times when you look at the statement and you go, I'm not sure how to do that, but if I turned it around and said n is odd and I prove it's even is actually easier, then do it by contraposition. They also have some divisibility. What time is it? When do we need divisibility? Later on. I might stop you in a little while to show you divisibility. If you have to prove an equivalence, to prove P is equivalent to Q, or P if and only if Q, which, by the way, we often write with a special notation, P if Q. 2 F's means if and only if. Then prove both ways. P implies Q and Q implies P. Just do proof in one direction, then prove the other direction.